Jai Hind all of you. I'm Dr. Rahul Bansal from Ajay Kumar Garg Engineering College, Gajwad. So this one is the next video lecture for the electronic devices KEC 301. So let us start. In this video lecture, we will be discussing about the transistors. Right. So basically, transistor mean transfer of resistor. One second. Transistor means transfer of resistor, right? So there are two type of transistors are there, PNP and NPN transistor, right? So first is PNP transistor. If you like draw this, it is actually 3-layer device. This side is called as P side, N side and P side. If at all, first layer is P side, second layer is N side and third layer is P side, right? This first layer is called as emitter. The second layer is called as base and third layer is called as the collector. Or you can say these are the terminals actually, right? So first one is emitter, base, collector. Then right. So in the NPN transistor, this emitter side is N. This emitter side is made up of N type of material. This base side is made up of P type of material and this collector side is made up of N type of material, right? So these are the two type of semiconductors basically, right? So based on these applications, we use the PNP or NPN transistor, right? Mostly we use the NPN transistor. Why? Because it consists of this emitter, which are the majority charge carriers, as an electron, and electron are having larger mobility than that of the hole. So we consider this as NPN transistor in the amplifiers and all, right? So okay, so this NPN transistor, if you see NPN transistor or PNP transistor, right, this width, if I talk about the width of this base side is very less. This base side is generally used to like for the recombination of the charge carriers, right? First, this emitter side width is moderate, or you can say greater than this base side, and the width of the collector side is very large. So why it is very large? Because all the majority charge carriers, right, they will like stuck at this collector side and they can affect the thermal stability. So to get the better thermal stability, this collector side is made very large, right? Talking about the doping concentration, this emitter side is having the largest doping concentration. Why? So why it is so? It can emit large number of majority charge carriers, right? So that the doping concentration of emitter side is very large, right? So I can just write is like as P plus, right? Next is this N side is moderately doped, right? This N side is in this PNP transistor, it is lightly doped, very lightly doped, that is N negative, you can just say. And this P side of the collector, P region of this collector is moderately doped. So I can just leave this as it is, right? So transistor, so this is basically the construction of the transistor, right? So if I talk about the symbol representation, right, if I consider this as like PNP transistor, this emitter side, so this is the emitter side, this one is the collector side, and this one is the base side, right? This emitter side, in the symbol representation, this emitter side will have the arrow. Either this will be towards this base side, and or it might be away from this. If it is like this, that is towards this, then this is said to be the PNP transistor. If this arrow is like this, away from this, then this is said to be NPN transistor. NPN transistor means emitter and collector will be made up of N type of semiconductor, and this base will be made up of P type of semiconductor, right? So you can just say, so you can see clearly, that is this collector base junction. Here we have the collector base junction, which is a PN junction, right? And another junction which is formed is emitter base junction, right? So we have basically two type of junctions: emitter base junction and collector base junction, right? Now, based on this biasing of the emitter base junction and the collector base junction of the PNP and NPN transistor, we define the region of the operation, whether the transistor is working in the active mode, saturation mode, cutoff mode, or inactive mode, right? So if I talk about the basics of the this transistor, so emitter side is like one side of the transistor, it will supply the charges carrier, right, to the other two sides, that is base and the collector, that we have like already discussed. Okay, if I talk about the NPN transistor, emitter of the NPN transistor will supply electron to the base and collector, and if I talk about the PNP transistor, it will supply the holes, because majority charge carriers are holes, to the other two sides, right? Next is collector, right? So collector, I have already discussed the major application of the collector, right? Next is base. Base is actually the middle portion of the transistor, right? So base is very lightly doped, it is very thin, right? So what does the base do? Base is actually used to control the flow of the charge carriers, right? Next is modes of the operation. So this is which is very important for the examination point of view, right? So broadly, transistor works in 4 different modes, but the applications are there in the 3 different modes, right? So these modes are decided with respect to emitter base junction and collector base junction biasing, whether it is forward biasing or reverse biasing, right? So 3 different modes are there in accordance with the applications. Otherwise, there are 4 different type of modes. Inactive mode is also there. So this inactive mode is rarely used for the amplifying purpose, but this is not like used, right, nowadays. So we can define this as like 3 type of modes, right? So first mode is the forward mode, forward active mode. So in this mode, see, we are having like this transistor. This is like emitter, this is base, this is collector, right? So we have two junctions. This one is like JE, that is emitter base junction, and this one is like JC, collector base junction, right? So four different possibilities may be there. That is, emitter base junction is forward bias, collector base junction is also forward bias. Second possibility is emitter base junction is forward bias, collector base junction is reverse bias. Third condition is emitter base junction is reverse bias, collector base junction is forward bias. And fourth condition is both the junctions are reverse bias, right? So take the first case, that is emitter base junction is reverse bias and collector base junction is also reverse bias. So in this case, it is said to be cutoff mode. The transistor is said to be cutoff mode. The application of this cutoff mode is generally in the switching condition. If I want to turn off this light, I can use the transistor. I can work the transistor in the cutoff mode. The light will be off or on depending on the situation, right? Next is, if at all your emitter base junction is forward bias and collector base junction is reverse bias, right? So in this case, the transistor is said to be in the active mode, right? So if at all emitter base junction is forward bias and collector base junction is reverse bias, it is said to be active mode. Next is, if at all both the junctions are forward bias, this condition is said to be like transistor is working in the saturation mode, right? And the last one is inactive mode. In this mode, emitter base junction is reverse bias and collector base junction is forward bias, which is like opposite to this active mode. So these are the four modes of the operation. If I talk about the application purpose, we generally use the active mode for the amplifying purpose, right? And the saturation and the cutoff mode, right? Saturation and cutoff mode are used for the switching purpose, right? So these are used in the like NAND gate, NOR gate, right? If you want to make the NAND gate, NOR gate, or any logical expressions, we can use this, right? And they are used in the cutoff or saturation mode. Now next is PNP transistor operation in the active mode. So if I consider this PNP transistor, right, and in the active mode, emitter base junction is forward bias, collector base junction is reverse bias, right? So this emitter base junction will be forward bias. It means that this P side is to be connected to the positive terminal of the battery, and this N side of this base is connected to the negative terminal of the battery. This condition, this junction, emitter base junction is forward bias. In the reverse bias condition, this P side is connected to the negative terminal of the battery and this N side is connected to the positive terminal of the battery. So this is said to be the reverse bias condition. So under this condition, this transistor is working in the active mode, right? So if you see the two junctions, right? If I increase this reverse biasing, that is VCB, if I increase this VCB value, right, such that the more reverse biasing is there, that is reverse biasing has been increased. If I increase the more reverse biasing voltage, that is VCB, right? So in this case, as base side is lightly doped as compared to the collector side, right? Depletion width will be more penetrated towards the base side, right? So due to this, what will be the effect? Effect is base width will be less, effective base will be less, and less recombination will be there, right? A point will come if you further increase this VCB value. A point will come when this base is completely damaged or base is completely removed. Under this condition, the transistor will be like it will burn, it will damage. This condition is called as the punch through or reach through, right? So changing in the voltage VCB, right, is actually modulating the base width. This phenomena is called as the base width modulation or early effect. Okay. If I talk about the current equations, so this IE is actually equal to IB plus IC. So this is the standard equation, right, for the ammeter current, right? Next is this IC, which is obtained, that is a collector current. It is actually the combination of the two currents, right? First is the majority charge carrier current and second one is the minority charge carrier current. So this majority charge carrier current is called as the diffusion current and minority charge carrier current is called as the drift current, right? So you can just write here majority charge carrier current and minority charge carrier current, right? So this minority charge carrier current is actually the temperature dependent parameter. So we should keep this as low as possible during the manufacturing, right? So we should try that this minority charge carrier current is as low as possible because it may lead to the less thermal stability of the circuit of the system, right? So this is all for this video. Thank you all of you. In the next video lecture, we will be discussing more about the transistor, right? And we will discuss in the detail about the early effect and all.